Good day, students. You are welcome to another episode of School on the Air. In the last lesson, the last class we had, we discussed about the algebra of 2 by 2 matrices. We talked about a null matrix. A null matrix has a 0 in the first row. It has zeros in the first row and 0 in the second row. We also talked about an identity matrix. We said an identity matrix, either you post multiply or you pre-multiply. You have 0, 1 in the first row and 1, 0 in the second row. We also talk about the singular matrix, that it is the determinant of a singular matrix is always equal to 0. Any matrix of when the determinant of a matrix is 0, you realize that type of matrix is a singular matrix. We also talk about how to get the determinant of 2 by 2 matrices. We discussed it that it's AD. When you have the elements A, B, then in the first row, then you have elements B, C, and D in the second row. Then you have AD minus BC as the determinant of that matrix. And I gave a lot of examples in the last lesson. Today we are going to another aspect. And this time around, we're looking at matrices and simultaneous equation. What's the relationship between matrices and simultaneous equation? You can use your knowledge of matrices to solve simultaneous equation. Simultaneous equation in the sense that you are solving two equations at the same time. That's the meaning of simultaneous equation. We can apply, and this has to do with two linear equations, because you can have one linear, one quadratic, but this is only applicable to two linear equations. When you are solving problem that has to do with two linear equations, you apply your knowledge of matrices, and that's what we're looking at today. We can use matrices to solve two equations. We can use it to solve simultaneous equations which are linear, actually linear equations in x and y. To do this, look at the illustration you have on the board. You have ax plus by equals p. Then down you have cx plus dy equals q. Meaning that you have this is the equivalent to what we have here. You have a, b, then c, d. Then you have the variable you are looking for, the x and y. You have it there. Then which is equal to the value you have after the equal sign. You have p and q in the bracket. So either you pre-multiply both sides by the inverse. You have ab, then cd. So you have 1, 0, 0, 1. Then you have xy equals 1 over the determinant of that matrix into the inverse of the matrix, which is d minus b minus ca, into the result you have after the equal sign, which is p and q. Or you have it like this: xy equals to 1 over the determinant of the matrix, then multiply by the inverse of the matrix. Then you have the result you have at the equal sign, p and q there. That's the equivalence. So what are we talking about? You can use we can apply this in solving problem that has to do with two linear equations that has variable x and y. So we want to look at how we can apply it in solving two linear equations that has to do with x and y. So let's look at the application. We have this example on the board, example 1, and that's what we're looking at. And we're going to apply the knowledge of matrix in solving these equations, two equations, and the two equations are linear. I'm emphasizing the word linear because it's only applicable to linear equations. You cannot use the knowledge of your knowledge of matrix to solve a quadratic, maybe one linear and one quadratic. But when it has to do with two linear equations, then you can apply the knowledge of matrix to solve the equations. So that's what you have on board. The example 1, you have solved this equation. The first equation is 3x minus 4y equals 1. That's the first equation. Then you have 7x plus y equals 23. That's the second equation. So how do we go about it? The first thing you are supposed to do is to write out the equation. Write out the first equation, which you have 3x minus 4y equals 1. That's the first equation. That's what we call equation 1. So the second equation is 7. You have 7x minus y plus y equals 23, according to what we have in the question. So you realize that when you look at the two equations, we look at the coefficient. You look at the coefficient of x for the two equations. Then you look at the coefficient of y for the two equations too. You write the coefficient out first. When you look at what I have here, you have the coefficient of x in the first one is 3. In the second one, you have 7. And for y, you have minus 4. And for x, for the other y, you have 1, according to the question. So you have x and y. Because that's the variable we're trying to get. We're trying to get the variable x, the value of the variable x, and the value of the variable y, which is equal to what we have at the equal sign. You have 1 and 23 there. So you move ahead. You have so when I told you the last time I talked about determinant, I said for us to be able to identify that you're actually looking for the determinant of a matrix, you use a vertical line, not a bracket this time around. When you're looking for the determinant of a matrix, you don't use a bracket, you use a straight line, two straight lines, one on the left and one on the right. That's why you have what you have there. You have the determinant of the matrix, that is the coefficient of the x and the y. You have 3, 2, then you have minus 4, then you have 1. So you can see the straight line, the two vertical lines equals 2. So I told you, you multiply how to get determinant is multiply 3 multiplied by 1. That's why you have 3 multiplied by 1 minus, don't forget that minus, then there is another minus. So you have minus, that's how you have plus here, multiplied by 7. That's why you have 3 plus 28. Because 4 times 7, of course, is 28. So when you add 3 plus 28, you will get what we have here, 31. So that's the general, that one we call it the general determinant of the two equations. That's the general determinant. That's D, represented by D, is the general determinant of that two equation, the matrix. So now you have to get determinant for the first variable, which is determinant for x. That's why I tagged it dx, meaning the determinant of x. And how do you go about that? Instead of inserting the coefficient of x, in this case, you insert what you have at the equal sign. Instead of inserting the coefficient of x in the two equations, you insert what you have after the equal sign. That's why you have 1 and 23 on this side. They are now replacing x, coefficient of x. Now you maintain the coefficient of y you have on the two equations. You have minus 4 and 1. So then you get the determinant of this. How do we do that? It's 1 multiplied by 1. You discover it's 1 into minus 4 into multiplied by 23. It's why minus times minus gives you 1 plus 92. Because 4 times 23 gives you 92. 1 plus 92 gives you 93. So that's the determinant of x. Determinant of x is gotten and is equal to 93. So the next thing is to get the determinant of y. So the same principle we apply in getting the determinant of x is that same principle we're going to apply in getting the determinant of y. So we have dy, that's how you have dy equals, then you have, these are the coefficient of x in the two equations, 3 and 7. Then you have the coefficient of y is no longer there. You are replacing with what you have after the equal sign, which is 1 and 23. So you get the determinant of y. How do you get that? Multiply 3 by 23. So you have 3 multiplied by equal to 3 multiplied by 23 minus 1 times 7. 3 multiplied by 23 gives you 69. And 1 multiplied by 7 gives you 7. So 69 minus 7 gives us 62. That is the determinant of y. So we move to the next stage. How do we get? What we are actually looking for is to get the values of x and the value of x and the value of y. What is the value of x and what is the value of y? That's what we're trying to get. And how do we go about that? We have gotten determinant of x. We've gotten determinant of y. So now to get the value of x, we will divide the determinant of x by the general determinants. Then to get the value of y, we divide the determinant of y by by the general determinants. And we have gotten all of this. We have gotten them. We have gotten the general determinant to be 31, determinant of x to be 93, determinant of y to be 62. So let's look at it. We have x is equal to determinant of x over general determinants. Y is equal to determinant of y over general determinant. So we realize that x is equal to, because the determinant of x is 93 and the general determinant is 31, that's 93 over 31. So y is equal to determinant of y over general determinant. And you realize that the determinant of y is 62 over the general determinant, which is 31. So 93 divided by 31 gives you 3. That's why it said, therefore x is equal to 3. And y, because 62 divided by 31 gives you 2, that's why you have y to be equal to 2. You can see it's very simple and straightforward to solve two simultaneous equations using your knowledge of matrices. Let's look at another example. This is the second example on how to use your knowledge of matrices to solve two linear equations at the same time, because the word simultaneous means at the same time. So how do we solve two linear equations at the same time? Let's look at this second example. We are asked to solve the equation. Look at the equation on the board. Look at it. So you have 6x plus 11y equals 29. That's the first equation, equation 1. The second equation is x plus 2y equals 5. That's the second equation. Look at the solution now. We write out the equation. The first equation is 6x plus 11y equals 29. The second equation is x plus 2y equals 5. So you bring out normally you bring out the coefficient of the x and the coefficient of the y and try to get the general determinants. That's what I did here. I brought out the coefficient of x in the two equations. So you have, for the first equation you have 6, second equation you have 1 as the coefficient of x. For the coefficient of y you have 11 in the first equation and 2 in the second equation. And you have the variable we are seeking to get, that's x and y, which is equal to what you have, 29 and 5. So let's see how it goes. So the first thing we have is we are to get the general determinant, and that determinant we have 6 and 1, then 11 and 2. I told you multiply 6 by 2, then subtract 11 multiplied by 1. So you have 6 times 2 minus 11 times 1, which is equal to 12 minus 11, which is equal to 1. So then you get the determinant of x, which is equal to, you place the coefficient of x with what you have at the equal sign, 29 and 5. So you have 11 and 2 there. Then when you try to get the determinant, you have 29 multiplied by 2, which is 58. Then minus 11 times 5, which is 55. 58 minus 55 gives you 3 as the determinant of x. Then you try to get the determinant of y. So you return the coefficient of x. Then you remove the coefficient of y and replace with what you have at the equal sign. So you have 29 and 5 at the y, where you have y, the coefficient of y, which is equal to 6 multiplied by 5 minus 29 multiplied by 1. 6 multiplied by 5 is 30. Then 29 multiplied by 1 is 29. That's 30 minus 29, which gives you 1 as the determinant of y. So what are the values of x and y? So we have x is equal to determinant of x over determinant of general determinant, then y is equal to determinant of y over general determinant. So we discover that x is equal to 3 over 1 because determinant of x is 3 and general determinant is 1. So you have 3 over 1, then y equals 1 over 1, meaning that the end result is x equals 3 and y equals 1. It's very easy to solve. So see how we can solve simultaneous equation using our knowledge of matrices. Now these are some of the questions that you have to lay your hand upon. You try to get these questions. And before we go, I don't want to forget that you have looked at today. We have looked at how to solve simultaneous equation using your knowledge of matrices. And for you to be able to understand it better and be able to solve any problem, that has to do with using your knowledge of matrices. You have to practice. So that's why you have the question on the board. You can try all those questions, and you can send your answers to the number you have on the screen. So you have the question: solve the simultaneous equation using matrix method. The first one is 7x plus 4y equals 29, 4x plus 2y equals 16. Second question: 2x plus y equals 3, x plus 2y equals 9. Then you have 21x minus 2y equals 15, 13x minus y equals 10. Then you have 4x minus 2y equals 9, x plus y equals 3. Then lastly you have half u minus half v equals 4, half u plus 1/3 u plus 1/2 v equals 7. These are the questions. Very simple question. They are not, as you and try them, I know you understand it better. And I hope you've enjoyed today's lesson. And I enjoy you to join me in the next episode of this School on the Air. And as you do, remain blessed. God be with you. Have a nice day. Bye.